All right, to this point, we've found the critical path through a precedence network using observation. That's pretty easy to do if your network is very basic. But if my network is complicated, we need a more systematic and trustable approach to finding the critical path. So can I please ask you from now on, for your test and your exam, whenever you draw nodes, it's not just a dot, it's an oval. Split it in half to look like that, and there should be space to fit numbers on either side. We're now going to do maths with your spider webs, okay? So this method that I'm about to teach you involves three things: a forward scan, a backward scan, and finding the slack time for each task. I'm going to demo the critical path method using this. So have that open. These are your exercises. Can you also have the three scans, the forward scan, backward scan, finding slack time beside you so we can refer to that each time? So you've got your network open in front of you. It's been drawn for you, but we're using the critical path method to find the critical path through that network. What is the forward scan? On forward scan, you go from the start node to the finish node and you follow the task arrows. What does that mean? I'm going from the start to the end. That makes sense. Why is it called forward? Because I'm going forward through the arrows, okay? What else do I do on the forward scan? On the forward scan, you record the earliest starting time, otherwise known as EST, for each task on the left-hand side of each node. So on the forward scan, you're filling in the left side of each node. You're filling in those sides. The EST of the start node is always 0. So straight away, every time I see a question like this, I put a 0 in there. The duration of each task is added to EST of the previous node as you move. So let's do that now. Is there only one way to get to this node? So I add 6 to 0. What would that be? 6. Is there only one way to get to this node? What would I add to 0? Good. This is the only other rule that you need for a forward scan. Are there multiple ways to get here? Yes. Are there multiple ways to get here? How do I handle that? If there's multiple tasks that meet the same node, you only record the largest EST. You ignore the other numbers. So there's multiple ways to get here. What would the largest number possible be that I could write on the left-hand side of that? No, but what would the total be? 7. Yes, you go through 3. But 4 plus 3 is 7. And I ignore the 5 that would go through the bottom. Okay? Now that I've dealt with that one, I can deal with this one. Are there multiple ways to get to this node? Okay, I want the biggest number. So 6 plus 5 is 11, or 7 plus 7 is 14. What number would I be writing? 14. Do I need to make a choice for this? There's only one way there. So 14 plus 4 is 18. Forward scan has been completed. Mission objective has been achieved. Forward scan done. Please remember, before this year, people had to remember this. This was memorized. You had no notes on the calculator for this test or the exam. Okay? So consider, if you practice this enough, I don't think you need that space in your exam cheat sheet either, because it's been done before. Backward scan. On the backward scan, you go from the finish node to the start node going against the task arrow. So what does that mean? You're going from here back this way. If you're doing it properly, you're going against the arrowheads. If you're doing a backward scan, you should be going in reverse of the arrowheads. If you go forward, you stuffed it up. Okay? Backward scan. On the backward scan, you record the latest starting time, LST, that goes on the right-hand side of each node. So on the backward scan, you're filling in this. You're filling in this. Okay? What do I do? The LST of the finish node is equal to the EST of the forward scan. So you can only do a backward scan if you've done the forward one. Why? Because I need to know that that's 18, so I can also write 18 there. The duration of each task is subtracted from the LST of the previous node as you move. Remember forward we added? Going in reverse, we take. 18 minus 4 would be? Good. Is there only one way to get to this node? Yes. 14 minus 7 would be? 7. Is there only one way right now to get to this node? 14 minus 5 would be? 9. Now we need to make some choices because there's multiple ways to get here, multiple ways to get here. What does my rule indicate that you do if there's multiple tasks that meet the same node on the backward scan? You only record the smallest LST. Remember, forward was biggest. In reverse, we put the smallest in, but the other LSTs, you write them in a box above the task that was associated with that. Remember in the forward, the number that we ignored, we completely ignored it. We didn't write anything. We just wrote the biggest. In reverse, we don't fully ignore it. So I'll show you how we deal with that. 7 is here. I've got multiple ways to get to this. 7 take 1 is going to be 6. 7 take 3 is going to be 4. We write the smallest in the node, but the other option, which was 6, we write it above the task that was associated with that. And then this last one here, the start node, 9 minus 6 would be 3. 4 minus 4 would be 0. So we write the smallest, but we don't ignore the other one. We write the 3 in a box above A. Can you get that copied down, please? I'll talk about the slack times. All right, finding slack time. The slack time of any task is the LST, the latest it can start, minus the EST, the earliest it can start. That slack time represents the time a task can be left alone. It can be delayed without changing when the task finishes. This whole project should finish in 18, right? Tasks that have 0 slack time, I can't delay, therefore they're the critical tasks. So when I find the tasks that have no slack time, that's the critical path through the network. So it's often useful that you use a table. In my test and in your textbook, you'll be asked to find the slack time using a table, but I've never seen the exam ask you to use a table. I'd rather you be able to use both ways, okay? So I'm going to copy this here and I'll show you how to fill that in. Where is task A? Task A is this one. The earliest start time for task A is 0. The latest start time for A is this 3 here. So what's the EST of A? 0. LST is the 3. So does task A have a slack time? 3 take 0 is going to be, I could leave task A alone for 3 minutes and it's not going to change the whole project from happening in 18 minutes total. Now let's look at B. What's the earliest time I can start B? 0. What's the latest time I can start B? Still 0, because that's what's in the note. So 0, 0. Does B have any slack? No. B must happen on time. Let's look at C. C is this one going up here. What's the earliest time that C can start? It can start at 4. And what's the latest time it can start? Also 4. Because that little boxed one is above D. So 4 and 4. Does C have any slack time? I can't slack with C. 0. Let's deal with D. What's the earliest that D can start? Still 4, but what's the latest it can start? That's what the 6 is. So 4 and 6. How much slack do I have on D? 2. I could leave D for 2 minutes and it's not going to affect the whole project. I'm still going to finish at 18. E, I don't have to think about it. E comes out of 6 and 9. So what's the slack time for, what do I enter for that? E is 6, 9, so slack time of 3 minutes. What about F? F is 7 and 7, so no slack time. And G, 14 and 14, no slack time. So you put stars next to any tasks that have no slack. So the critical path through this network is going to be B to C to F to G. How long is that going to take? B's 4, 5, 6, 7 for C, 7, 14 for F, 18, whatever the units were. We don't know what the units, 18 units of time. Why is there slack? What does the slack mean? Well, see how in total going down through here, that's 7, 8, 9, 10, 11, 12, 13. That whole path there is 14 minutes. What's the path up here? 11. What's the difference between 14 and 11? Does that explain why I can leave A alone for 3? Because if I left the 5 alone for 3, it would delay it too much. Okay? Why can I delay this by 1? No, 2. Yeah, why can I delay this by 2? What's the slack time here? 2. Why can I delay it by 2? Because it takes 1 minute and the other option takes 3. So I can slack it off for 2 minutes to keep the same time. And student over there, a lot of you may think right now there's only possibly one critical path through a network. There can be multiple, okay? Just as long as you apply those rules to your scan, okay? You won't admit it right now, but when you get the hang of this, it can be kind of fun to just hammer one and just get it perfect straight away because you just followed the rules. It's kind of nice when it sort of lays into, it all fits to plan like a puzzle or something. It's kind of sick, all right? So could you do 12.8.3? That is half of your topic done.